Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through terminating and recurring decimals. We're looking at two types of decimals here. Those that stop, which are terminating, and those that go on forever and have a pattern, and they are recurring. So you probably know decimals are just another way to write fractions. You probably know, for example, a half is the same as 0.5. Hopefully you also know something like 3/4 is the same as 0.75. So these two decimals, 0.5 and 0.75, they are examples of terminating decimals. They are terminating because they stop. The numbers after the decimal point stop. So after 5, there are no more numbers after the decimal point. It stops. Same here. This stops after two numbers after the decimal point. But that's not the same with all decimals. If I want to write, say, 1/3 as a decimal, it's actually 0.333333. The threes go on forever and ever. They never stop. So in maths, these three dots means goes on in that pattern forever. So 1/3, 0.333 goes on forever. But there are heaps of numbers like that. 5/12. If I want to write that as a decimal, it goes on forever. It's 0.41666. The sixes go on forever. 3/7. If I want to write that as a decimal, it goes on forever. It's actually 0.428571, and then this cycle repeats over and over. 428571. On and on it goes like that. It just keeps going. 428571, 428571, on and on forever. All of these decimals go on forever, but there is a pattern to the numbers. We call those recurring decimals. So some fractions have terminating decimals, some fractions have recurring decimals. So we want to come up with an easier way to write this. See, 1/3 is not 0.33. It's actually a little more than 0.33. So a way we write that is like this, 0.3 with the dot on. This dot here means the threes go on forever. So how would we write this in the same way? Well, we'd write it as 0.416. We only put a dot over the 6 because here, the 4s and the 1s, they don't go on forever. Only the 6s do. So when you're writing it like this, you only put a dot over the things that are repeated. For this last one, 0.428571, everything is repeated. So we write 0.428571. There are two ways that you can do this. So first way, you can put a dash over the whole lot like this. So that means everything under that dash is repeated. The 4 is repeated, so is the 2, 8, 5, and 7, and 1. So that is the case because the 4s keep happening, the 2s keep happening, whereas in this case, the 4 didn't keep happening. There was only one 4, and then there were no more 4s. The other way you can write this, you can put a dot over the first number in the sequence and the last. And that just says that everything between these two dots goes on forever and ever. So what I've written in black is called exact form. That's how we write recurring decimals exactly. See, I said before that a third, it isn't 0.33. The threes go on forever, but I can't possibly write threes that go on forever. So I write it like this, 0.3, the dot tells me the three's gone forever. This is exactly equal to 1/3. It's not rounded. If I wrote 0.33, that would be rounded. This number here is exactly equal to 5/12, and this number here is exactly equal to 3/7. So whenever you're asked to write a recurring decimal in exact form, that's what it means is you write it with the dots. You just put a dot over the numbers that are repeated. All right, now we're going to look at converting fractions to terminating or recurring decimals. So to convert a fraction to a decimal, you use the short division algorithm. And you use that algorithm whether the fraction is terminating or recurring. It just turns out if it's terminating, you'll know to stop. And if it's recurring, you will see a pattern. So let's say, for example, I want to write 5/8 as a decimal. So it's 5 divided by 8. Another way to say that is how many times does 8 go into 5? So 5 is the same as 5.0. I'm just going to write a few zeros here. So this is how we do it. We say, how many times does 8 go into 5? Well, the answer is 0, remainder 5. So we put a 0 here, the remainder goes up here. Very important when you use short division, decimal point needs to go above the decimal point. So now we say, how many times does 8 not go into 0? How many times does 8 go into 50? So the answer is 6, remainder 2, because 6 times 8 is 48. And then if you add another 2, you get 50. So now I say, how many times does 8 go into 20? Well, it goes in 2. 2 times 8 is 16. Remainder 4. How many times does 8 go into 40? Well, it goes into 40 5 times, but no remainder. So I put the 5 up here, and because there's no remainder, I stop. I'm done. 5/8 is equal to 0.625. 5/8 has a terminating decimal because the decimal stops after 3 spots. So let's look at another example. So instead of doing 5/8, we're going to do 5/6. So that's saying how many times does 6 go into 5? So again, I'll just write a few zeros here. Okay, so same idea. So we go, how many times 6 go into 5? Well, it goes in 0 times, remainder 5. Once again, decimal point above decimal point. So how many times does 6 go into 50? Well, 6 goes into 50 8 times, remainder 2. How many times does 6 go into 20? Well, 6 times 3 is 18. It goes in 3 times, remainder 2. How many times does 6 go into 20? Well, 6 goes into 20 3 times, remainder 2. So I'm going to put in another couple of zeros here. So the remainder's 2. So how many times does 6 go into 20? Well, it goes in 3 times, remainder 2. How many times does 6 go into 20? It goes 3 times, remainder 2. So you can see we're in a bit of a loop here. Each time I'm going to get 6 into 20, I'm going to get 3, remainder 2. This process is just going to go on and on and on. So I can stop there. I don't want to do this forever. Maths is awesome, but it's not that awesome that I want to do it forever. So this is just going to keep going and going and going and going and going. So what I found is 5/6 is actually 0.83, but the 3's go on forever. So 5/6 actually has a recurring decimal. It's 0.833333. The 3's go on forever. I know that because what happened here wasn't the same as what happened here. Here I got a clean division, 8 into 45, no remainder, and I stopped. But here this is never going to happen. I'm going to keep getting a remainder of 2 each time. I'm going to put a 3 up here and get a remainder. So that's why this goes on forever, whereas this didn't. But as soon as you see the pattern, you can stop and just write it in exact form. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.